So here are your notes, solving systems of equation by elimination. In the book it talks about adding, but we're going to be doing some adding and subtracting and basically canceling out either the x or the y term in order to find both terms in the end. We have to think about this as two linear equations, and if we graphed them, where would they cross? That's what we're looking for. So by the end of this lesson, you will be able to solve these algebraically instead of doing the graph. So these are your notes, 1117, it's page 71, and the date is actually 3/18 because we are doing these for Monday the 18th. Again, the date is 3/18, it's page 71. We're going to find the point of intersection by finding the x and the y coordinate. So if I take a look at these two equations, I can see that I have a negative 1y and a positive 1y, and I know that together that equals 0y or just 0. So those are the two terms that we're going to eliminate. And here we are going to eliminate by adding, and we have that we're going to add the other terms also. So we have 2x plus x gives me 3x equals 2 plus 2, which is 4. In order to solve this equation, all I have to do is divide both sides by 3, and x is equal to 1 1/3. In order for me to find the y coordinate, I need to take either one of those original equations and plug my 1 1/3 back in for x. So I'm going to use x plus y equals 2. And I'm going to do 1 1/3 plus y equals 2. And I can subtract 1 1/3 from both sides to get y equal to 2/3. So the coordinate or the point of intersection for these two linear equations is the x coordinate 1 1/3, comma the y coordinate 2/3. For example number 2, it looks like if I subtract my x's, they will cancel out, which means I need to subtract the y and subtract the 5. So these will cancel, and I have 3y minus 1y, which is positive 2y, and I have 13 minus 5, which is 8. If I divide both sides by 2, I get that the y coordinate this time is 4. And that's fine that we get the y coordinate first, because you would get the same answer even if you had found the x coordinate first. I'm going to use the equation, the original, x plus y equals 5. That was the original. I'm going to plug in my 4 for y, so I have x plus 4 equals 5. And let's think about it. What plus 4 equals 5? Well, x equals 1, because 1 plus 4 equals 5. So our x coordinate being 1, our y coordinate being 4, those two linear equations will cross at the point 1, 4. Little different of linear equations this time. They're using a and b, and we just follow the alphabet that a and b are going to correspond to the order x, y. So a is kind of our x, b is our y coordinate. Now, looking at these two equations, neither the a's nor the b's are going to cancel out right away. So here's what I do. I'm going to adjust the first one. And I'm only picking the first one because I can do a simple multiply by 3 to get the b's to have the opposites that will give me that 0. And so my new equation is 15a plus 3b equals 39. You have to multiply the 3 by every single term. It's kind of like you're distributing it 3 times. The second equation I have not changed, but look, now I have that plus 3 minus 3 to cancel out the b's. So I'm going to add these two equations together. I have 19a. These b's will cancel, and I have 39 plus 18, which will give me 57. I divide both sides by 19, and I get a is equal to positive 3. Now would be a good time for you to try to find b on your own, so pause the video And now I'm going to take the original equation. Either one will work. I'll get the same answer. And I'm going to put in 3 for A. So I get 15 plus B equals 13, minus both sides by 15, and I get that B is equal to -2. So the point of intersection of these two linear equations, A, which is +3, and B, which is -2. So this is the final answer that we're looking for in each of those. An ordered pair where the two linear equations, if I graphed them, they would cross at that point. Little Regions review for number 4. It says, what point is the intersection of the graphs of the lines 2x minus y equals 3 and x plus y equals 3? So let's write these one on top of the other and see if there's anything that looks like we can eliminate right away. And it looks like I can add these two together and the y's will eliminate. So I have 3x equals 6, 3 plus 3. Divide both sides by 3, and the x term is 2. Now there's only one answer that has an x coordinate of 2, and that's choice D, 2, 1. So let's do a quick check. X plus y equals 3. 2 plus y will give me 3, and so it has to be that the y coordinate is 1. So D is our correct answer. Another Regions review question. It says the equations 5x plus 2y equal 48 and 3x plus 2y equal 32. This represents the money collected from school concert ticket sales during 2 class periods. X is going to represent the cost for each adult ticket, and y is going to represent the cost of each student ticket. So what is the cost of each adult ticket? So we are solving for x. We are just trying to find the x value. And so if I write these two in the form that we've been using, is there anything that looks like we can cancel out? And if right away you think you know what to do, pause the video, solve it yourself, and see if you can get the same answer as I do. So I'm going to subtract these two. So I'm going to subtract, so that I can get them to cancel out the y's. And that's good because I really want to know what the x is for the adult ticket. So this 5x minus 3x is 2x. 48 minus 32 will give me 16. If I divide both sides by 2, I get that x is equal to $8. Choice B. So that sums up solving systems by elimination. You are looking for those two linear equations to cross at a specific ordered pair. We will practice examples tomorrow in class or on Monday in class. So have a great weekend.